Okay, so of course, by now, everyone has figured out that there is only one x squared, right? It has to live in one of the corners. Now, most of you grabbed the 8 and started trying to work with them. And most of you I watched, you put 8 out this way. That made a nice rectangle. And then what do you do with the 7? Oh, damn, didn't work. Some of you did this move. What? And started putting the little ones in there. That didn't work. So, of course, the 3 groups that got it right away recognized that 8 can exist in a whole bunch of ways. But 7 in a rectangle can only exist in one way, which is 1 by 7. So they said, all right, since this 7 has to be by itself, they went out here, 1, 2, 3, 4, 5, 6, 7, and then noticed, hey, there's 7 bar gaps there and an 8th right there. The groups that figured it out started with the 2 easy ones, the x and the 7. Now, in this empty spot right here, I want you to write the following. ax squared plus bx plus c. That is what we call a general form of a trinomial. Now, please notice, in this trinomial that we were working with, there isn't really an a written there, but there's really an a there, yes? In this trinomial, a equaled 1, b equaled -8, and c equaled 7, right? So, we drew this. Now, once you've drawn it or made your rectangle, you know that the edges are where the factors live, right? Just like back in grade 3 when Mrs. Bad Crumble showed you 4 by 2 to make 8, right? The factors of 4 and 2 lived on the outside. 8 was the product in the middle. So here, what is this? On the edge, that's an x. And then 1, 2, 3, 4, 5, 6, 7. X plus 7. Right? Or sorry, wait. These 8 were all negative. So these 7 had to be negative, right? So x minus 7. And down here, what's that? X. And what's that? 1, but what kind of 1? Had to be a -1 to make this negative. And then the other side was x minus 1. Now, please notice, if I do distribution here, what do I get? X squared minus 1x minus 7x plus 7, right? X squared minus 8x plus 7, which is what I wanted to do. Everybody cool? All right. I want you now to take your algebra tiles. We're not going to draw it. You're just going to practice it. Well, I'll draw it to see if you've done it right. I want you to show me x squared plus 9x. No, not 9x. Sorry. X squared plus 3x minus 4. Build that with your blocks in your groups. Shouldn't take very long. When you're done, pat your head and rub your tummy.
Oh shit.
Why do I see nobody patting their heads and rubbing their tummies? There we go. Let's see.
But you have 4 X's then.
Oh.
Booyah, Grandma! Booyah, Grandma! Guys. Oh my God.
What?
Don't tell us your powers. Yeah, I fucking no, just tell me that. No, bitch. This is impossible. Oh, really? Oh, I think I got what they want. Yeah, what is this question? Mike, no, then I can't. I don't know how you choose this.
Okay. Did you get the last one?
Yeah.
Where did you start in the last one? You started in the corners, right? So where are you going to start with this one? In the corners. X squared, we're locked in. There's only one. 4, we have 2 options. You could have 1, 2, 3, 4. Or you could have a string of 4, right? Now, these... Okay. Don't forget that half of the infinity of numbers you have available to you are negative.
Oh. So, okay.
Well, without that knowledge, Roy, you can't do this question. So why are you saying so?
It's funny.
All right, so, ladies and gentlemen, once again, there's my X. My options for this corner are 2 by 2 or, sorry, I wanted to use a different color, or 4 by 1, right? Now, the 4 is negative, yes? So all of these need to be shaded in. Agreed? Okay. So now I have either 1, 2, 3, 4 spaces to fill with X's, right? Or 1, 2, 3, 4, 5 spaces to fill with X's, yes? Now, all those X's have to be positive. All right, well, if these are all positive, then, okay, how do I get this to be negative? Either that has to be negative or that has to be negative, right? Okay, so if this is negative, then doesn't that make this negative? So I'm screwed. It can't be that. So let's come over to here. All right, these are all negative. Okay, so positive x, 1, 2, 3, 4. Those are all positive. Positive x, and what's this? If I make that negative, x times x, x squared positive, x times negative 1 makes this what? Negative. Positive times positive, what? Positive, 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 positive. 4 positives and 1 negative. What happens? Cancel 3 x's, and there's my 4. And I made a rectangle. What are the factors? X minus 1 and x plus 4.
I was only thinking about making a rectangle out of the actual measurements of the physical item.
Don't. Is everybody good? I don't know how else to show you.
No, this makes perfect sense. I understand.
I will give you one more to try. X squared plus 5x okay. Minus 6. Cluck like a chicken. No, it's cluck like a chicken this time. Oh, lots of people clucking like chickens today. You city kids. Chickens. All right.
Never listen to me. I am dumb.
X squared, no problem. Where do we look next? We have to look at the 6, right?
Yes.
What are my choices for 6? 6 by 1 or 3 by 2, right? If I go 3 by 2, 1, 2, 3, 4, 5 x's, yes? That's what I'm supposed to have, correct? But this is a negative, so these all have to be colored in, right? What's the only way to have negatives here? I would need a negative there or there, correct? If I have a negative in either one of those places, that would make some of these x's negative, wouldn't it? And I can't have that. So it mustn't be 3 and 2. What's the other option? 1, 2, 3, 4, 5, 6. Yes? All negative. Agreed? Okay, so now I have 1, 2, 3, 4, 5, 6, 7 spaces to fill, yes? That is x, has to be positive. That is x, has to be positive because this is positive, right? This is negative, so this has to be what? We're going to make that one positive. If that's positive, what does that make this? Negative. What about all the rest of these? They're all positive now, correct? Now let's check. If that's negative, what's positive x times negative 1? Negative x. So that one colors in, yes? Now, what does that colored in one do with that not colored in one? Cancels it out. 1x squared, 1, 2, 3, 4, 5 x's, and 1, 2, 3, 4, 5, 6 negatives. All right? Okay, now, come back to your page 76. Bag up your algebra tiles. When they're bagged up, you may just leave them on your desk. All right, so everybody has gathered up their algebra tiles? Now, what do these brackets do to x plus 4?
It makes it one group.
Makes it one single thing. If you know what x is, if I tell you x is 2, what number would go right there? 6. And what number would go right there?
8.
And 6 and 8 would be factors of the product 48, right?
Yeah.
Okay. So if you know what x is, you would multiply this times this, yes? Okay, you don't know what x is, so let's multiply this times this. What's x times x? What's x times 6? What's 4 times x? What's 4 times 6? And I get a final answer of x squared plus 10x plus 24, right? Okay. Now, I would like for you to think about what we just did with the tiles and what you just did with the numbers. What do you notice about this row in the middle and this number in the middle? What did we do? We added them. What do you notice about this number at the end and these two numbers at the end? You multiplied them. So now, remembering what we wrote up here, we know that to factor ax squared plus bx plus c, we need to find two numbers that do what? Add to what? Which is B. And multiply to C. That's it. Now that makes sense the way we built it, right? We had to think about the multiply first. Everybody cool? Now let's think about what we just did. We did x squared minus 5 or plus 5x minus 6, right? That was the last one we built, yeah? And we got x plus 6 and x minus 1, right? Okay. X plus 6, x minus 1. 6 times 1 is negative 6. 6 minus 1 is 5. Let's look at the first one we did. X minus 7, x plus 7, or x minus 7, and x minus 1. 7 times 1, positive 7. Negative 7 minus 1, negative 8. Everybody with me? Can I ask why? Where? You're not writing anything down. How can you possibly know where I lost you? Can you do this? Then do you recognize that 6 and 4 was 10 when you add them? And 6 times 4 is 24. Okay. Do you recognize that this is a letter B? Do you recognize that that is a letter C? Do you recognize that I need to find two numbers that add to B, like 6 and 4, and multiply to C, 24? So in this question, there is B, there is C. So I must need two numbers that multiply to C, which is negative 6, and add to B, which is positive 5. What are the numbers that multiply to 6? 1 and 6, and 2 and 3. 1 and 6, and 2 and 3. How will one of them get me 5 when I add them and multiply them to negative 1? If I need to multiply to a negative, one of these must be negative, correct? So if that's negative, and that's negative, what's negative 1 times 6? Negative 6, so that would be okay. What's negative 1 plus 6? Positive 5, so that is my answer. 6 and negative 1. Now we go up to the first one we did. There is B, there is C. I need to multiply to 7 and add to negative 8. 7 is only 1 and 7. How does 1 and 7 add to 8 and multiply to positive 7? They both must be negative. And now I am done. When you turn the page over, you see a whole bunch of these. All of you should be able to do A, B, C, D, and E right now. You shouldn't even need to think too hard about it. But we're going to do the first couple together. What must I multiply to in A? No. Again, thank you, Mackenzie. Answer the question I ask. And what do I need to add to? Is it 1 and 18? Is it 2 and 9? How do 2 and 9 make 7? 9 minus 2, correct? X minus 2, X plus 9. Mr. Myers, did I do it right? Did I do it right? Check it. What's X times X? What's negative 2 times 9? Negative 18. If the ends are right, the middle's right. What do I need to multiply to in B? Negative 8. What do I need to add to? Negative 2. Is it 1 and 8? Is it 4 and 2? How do 4 and 2 get me negative 2? 2 minus 4 is negative 2. So does x minus 4, x plus 2. Mr. Mize, did I do it right? Did I do it right? Check it, kid. X times x is x squared. Negative 4 times positive 2, negative 8. Did I do it right? Yes. Is this allowed? I asked for a yes or a no. Yes. Why? Because multiplying is commutative. 3 times 2 is the same as 2 times 3. Is this allowed? No. Why not?
Because they don't multiply to the same thing.
When I expand that out, I don't get this, do I? Good. What's C? X minus 7, x minus 5. Look, you're starting to get them in your head. What's D? Everybody says 10 and 2. So it's A plus 10 and A minus 2. I need a negative 20. One of them has to be negative. If I make them both negative, I get negative 12, but I would get positive 20. There you go, Shayla. Say it loud and proud. It doesn't factor. That is the equivalent of a prime number. So that would be 1 times a squared plus 12a minus 20. Would I ever write 1 times anything?
No.
So that doesn't factor. So it's already as simple as it gets. So we leave it. The reason that is in your notes is because if I didn't put it there and I sat here and didn't talk to you about it, you all would spend about 20 minutes arguing about trying to force that into the rule when it doesn't work. Okay? Now, let's look at E. All of you should be able to do that in your head. Y plus 2 and y minus 7. Can everybody do this?
Yes.
All right. Look at F. Tell me what's different.
Oh, no.
Abby. We don't like that 4 out in front. But fortunately, Mr. Myers explained something yesterday about factoring, and he said to... What?
Do that.
Greatest common factoring. What do you see there, and there? Numbers that are divisible by 4. So I have to do my GCF first. Can I forget about the 4? No. How many of you will forget about the 4? All of you. 4. X squared minus 5x minus 14. Hey, that looks pretty familiar. So that is 4x minus 7x plus 2. Everybody good? Excellent. Now take what I just showed you and do G by yourself. Go.
Wait.
I am waiting.
Shouldn't that be, the whole thing be in brackets on question F? At the very final answer, shouldn't the whole expression...
You want to add extra brackets there?
Yeah.
Why? That looks more complicated to me.
I don't think it's falling. I guess it's not necessary.
No, not at all. Would you write extra brackets for this? 4 times 2 times 7? No, because 2 is a single thing. Don't those brackets make that a single thing? So we're done. Everybody try G. Or to quote my elementary school teachers, try number G. Delightful. Who will become my puppet master? What must I do? Which is what? 10. Can I forget about the 10? No. 10x squared plus 8x plus 12. Have I factored?
Technically, yes.
Yes, I have factored. Have I finished factoring? No. Because I, of course, need numbers that multiply to what? And add to what? And what are they? Brilliant. What bothers you in H? It's a negative 4. How do I get rid of it? Divide by negative 4. And get t squared plus 4 minus 32. Have I factored? Have I finished? Finish it. Like in Mortal Kombat. Finish it. I want to see that trinomial's spine dripping with blood like the way Scorpion does it. Unless you have Nintendo, Super Nintendo, from the original Super Nintendo Mortal Kombat where they took all the blood out of it.
You can use that.
I don't care.
I'm sorry. I thought that would be cool.
Unlike you guys, I don't need to see extra blood to enjoy a video game. And what is the answer? Minus 8? Minus 4 plus 8. Yeah? Yeah. What bothers you in I?
You can't choose it.
You don't like the order. Can you move it? Sure you can. Negative d squared minus 5d minus 24. Now what bothers you?
All of them are negative.
So what do we do?
Make them positive.
How?
Over the one.
We divide by negative 1. And we get d squared plus 5d plus 24. Have I factored?
Yes.
Have I finished factoring? Yes, I have. Because what are the factors of 24 that add to 5? None. You want to say 8 and 3, but since that's positive and that's positive, there's no subtraction, so you're done. Now, what bothers you about J? Different letters, first of all. Oh, I can't do it when it's different letters. We all know the kind of horse crap I think that is. So what else bothers you about J? There's a second letter. Now, take previous knowledge and bring it to the new party. When it was v squared, or t squared, or x squared, or y squared, or d squared, we ended up with v and v, right? So obviously, what do I need at the other one? I need b and b. Does anything else change? Of course not. So I need numbers that multiply to what?
20.
Negative 20 and add to what? 19. Is it 1 and 20? Of course it is. It is V minus 1B and V plus 20B. Would I write that one? No. Does everybody get it? Excellent. That means you can do K by yourself. Go. Oh, Mr. Myers, yes, you can go to rugby. This is being videoed. You can watch it later. And I'll see you in 40 minutes. Don't cheat. I'm refereeing their game. The girls' rugby team. I got my eye on you. Not you, Mia. You would have your eye on me because you're a lifeguard. I got to go to your pool and put my kids on my shoulders.
I don't work there.
Oh.
I just have a
Can you be loose on this here? Can I just like full send for your people? Just full send.
If you want to cheat.
How cheating? Okay, what if I stay on my feet and I run?
Okay, listen. To create a ruck, if you read the law, you must bind onto another player.
Okay, so if I wrap and then clear all the people.
Yes, and you come straight through the gate. But the way they do rucking on TV, which is what all of you see, is they just slam into them like a missile. Referees should be calling that. That's not law, but it makes for good TV.
But all the professionals.
Yes.
But then shouldn't it be played by?
You're a professional?
No, I'm saying, but if those are the best players in the world, you should want to say that. Well, I guess then it's not your decision. I mean, it is your decision.
All right. So what's this one? X plus 14y and x minus 2y. Look at how brilliant you are. What bothers you in L?
They're all exponents. So we gotta do the rooting.
What bothers you in L?
It's got A squared B.
It's got too many whats? Too many letters. What letter occurs in all the terms?
B.
So is there a GCF?
Yeah.
So what should we do?
Yeah.
We don't yeah it. What should we do? We get rid of B. How many of you will forget to write B out here? All of you. A squared minus AB minus 20B squared. Finish factoring that.
Oh. Okay. Yes. Absolutely.
What do I need to multiply to? What do I need to add to? I can't believe I am waiting this long for the answer.
Oh, okay. So first you do that. No, wait, no.
It's exactly like... No, we haven't done these exact numbers, but... Just waiting. Nothing but time. But you do know, because we've just done 10 of these. What must I multiply to? Negative 20. What must I add to?
A1.
Negative 1. Is it 1 and 20?
Yeah.
1 plus 20 makes negative 1. Is it 2 and 10? Say it loud and proud, Mackenzie. 5 and 4. How do 5 and 4 add to negative 1? Negative 5. A minus 5B times A plus 4B. All right. Look at M. What bothers you? There's 4 X's. You're smart kids. When there were 2 A's, we did A and A. When there were 2 X's, we did X and X. When there are 2 K's, we do K and K. When there are 2 M's, we do M and M. Well, now there's 4 X's, so what must I need? X squared and X squared. Then do you think anything else changes? No. What must I multiply to? 50. What must I add to? Negative 15. What is it? 5 and 10. Positive or negative? Wrong. Negative for both. Thank you, Gideon. Because negative 10 times negative 5 is positive 50. Negative 10 minus 5 is negative 15.
Negative 15.
What bothers you about n? We would never write that, would we? But I have written it there for teaching purposes. Get it? A dolphin? Yeah. So,
first step, don't we just, so first step we would multiply x by 0, right?
Now, hold up. Hold up.
Holding up. The up is held.
This would never be written there, yes? But I've written it there so it looks like all the other ones, right? Okay. So since it looks like all the other ones, let's approach it like all the other ones. I must multiply to what? Negative 9. And add to what? 0. Is it 1 and 9? Is it 3 and 3?
Yes.
So it is x plus 3, x minus 3. Now, I am going to ask you to remember that for a few days. And I'm going to ask you to apply that to here. All of you should see a really handy shortcut right now. X plus 25, x minus 25. Why did you know that? Same thing as here. I square root and I square root.
Hey, looky there. Now we know how to do binomials.
Square root, square root. Now look at this. This one's slightly different, isn't it? But it shares some characteristics with n and o. What characteristics does it share? These are both perfect squares. Now, if you didn't see that, could you follow what we've been doing all the way along? You would need to multiply to 16 and add to 8, right? What is it? 4 and 4. X plus 4, because they're both positive, and x plus 4. Or you see the shortcut. Wait a minute. Squared, squared, xx, 4, 4. 4 plus 4 is 8. I got it right away. Everybody good? All righty then. I want for you today to work on page 78. And only page 78. I know it says assignment, but we're nearing the end of the day. We'll just make it practice. When do I expect to see this done? Tomorrow. Which is when does the day end? In 26 minutes. Should you be able to get this done with and have no math homework? You're darn tootin' you should be. Go. What? Okay, so... Well, then I guess you'd better work extra efficiently, Roman. If you don't want